Alright, in this lesson we're going to find the equation of hyperbolas if we're given the graph or characteristics of the graph. And before we do that, there's a formula that will help us answer a common question. And if we have the general form in this form of a conic, what is it going to be? What will it be? A parabola, hyperbola, ellipse? And here's how we tell. And a way to help you memorize this is if it's greater than 0, then hyper means above. So greater than 0, hyperbola. Equal to 0, think of a pair, parabola. And then the other one would be, oops, that should be a less than, ellipse. So in this problem, we're looking for A, B, and C. There's A, but then we have to put it in order. And we have B squared minus 4AC with B being 6, A is 3, C is 3, and 36 minus 36 equals 0, so that is it is a parabola. Pause the video and try that one. Identify the type of conic. We want to get the x squared and the y squared on the left. We'll go ahead and finish the other terms, even though we don't need them. So b squared, 2 squared, a is 6, c is negative 3, and if we multiply this, we're going to be 4 plus something, so that's going to be greater than 0, and it is a hyperbola. start by graphing, and we're going to do positive 3, 0, negative 3, 0. Those are the vertices, and the foci will be 4, 5, 6, and 4, 5, 6. So if that's all we know that the hyperbola has to go like this around the foci, and that tells us that in the equation we're going to have x first, so it's x minus something and we know that the center is 0, 0, so we can put that in. And this is the number under the x is the distance, the horizontal distance away from the center. So this is 1, 2, 3, and we know that's going to be there, and we need to find this. So in the, let's use the foci to find this, and we'll say that's b. So c squared equals a squared plus b squared. C is 6. A is 3. Solve for b. And we don't need to simplify that because we're just going to square it. This is radical 27. B is radical 27. So if I put radical 27 in there and square it, it's just going to be 27. Okay, pause the video and find the equation of the hyperbola. 0, 2 is a vertex. 0, negative 2 is a vertex. So in this graph, the hyperbola has to be opening like that. If it's opening vertically, then we know that y is first. The center is 0, 0, so we know that. The vertical distance that we move is 2, so we know that. Then we have to find b. So we have c squared equals a squared plus b squared. C is 4. A is 2. And we'll have 16 minus 4. We are only looking for b squared, so we could just even leave it like that. Y squared over 4, x squared over 12 equals 1. And here we're not going to have a center at the origin, so it'll look a little different. Those are the vertices, so we see the center is there, and the foci will be up 5 and down 5, and the hyperbola must open like that. That tells us that since it's opening vertically, we'll have y first. And we just fill in the blanks. We have a center with an x value of 2, so that'll be there, a y value of 0. The vertical distance is 3, so that'll be under the y. Horizontal distance we don't know. And c squared equals a squared plus b squared. C squared, this is going to be 5 squared, 3 squared, and then we have the equation. Y squared over 9 minus x minus 2 squared over 16 equals 1. Okay, pause the video and try that one. Vertex at -2, 1 and +2, 1. Foci -3, 1, +3, 1. That means the hyperbola is opening horizontally, and we know that x comes first in the equation. And we have to find the center. Well, that's right there. X value of 0, y value of 1. We have a horizontal distance away from the center of 2, so that's under the x because x is horizontal. And we need to find that. C squared is a squared plus b squared. And c is 3, so we'll have 3 squared. A is 2. And we have 9 minus 4 is b squared. B squared is 5. X squared over 4. Y minus 1 squared over 5 equals 1. Alright, so here we have a different characteristic given. So we plot the vertices and the asymptotes. Slope of 3, that means we're going to go up 3 over 1. And we have an asymptote like this. And then we'll have the other one over there. Since the vertex is here, we know it has to open that way. And that tells us that y will be first. And we know that 3 is under the y because it's a vertical distance, so it's under the y. The center is 0, 0, and we're looking for this. With this example, we can see that b is going to be 1. But if this were reduced or maybe in a different form, we have to be careful. So if the slope is always going to be, well, in this case, b over a. Nope, it's a over b. The slope from the previous lesson was always the number under the y, the rise, over the number under the x, the run, rise over run. And so now we have a slope of 3 over 1, and we know that the 3 in the equation over b, so we can see that b is going to be 1. But maybe if this were a different fraction, or this could be reduced and we have different numbers there, then we make this proportion and we can see that b equals 1. We have 3b equals 3, and that's everything we need for the equation. So the equation is y squared over 9 x squared over 1 Pause the video and try that one. Alright, vertices at 2 and negative 2, asymptotes, slope of 1 over 4, up 1 over 4, and so the hyperbola must be inside here. And it's opening horizontally, so x is first. The center is 0, 0. We have a horizontal distance of 2, and that goes under the x because it's horizontal. We're going to solve for b. In this case, slope is b over a, because I always have to have the denominator of the y for the rise over run. And the slope is 1 over 4. Here we know that a is 2, so b over 2. And that means we have 2 equals, or we'll just multiply by 2. 2 over 4 is b, and b is 1/2. So in the equation, it's x squared over 4 minus y squared over 1/2 squared. All right, one more is the last type of example. negative 2 up 1. And we're going to do positive 2 up 1. Those are the vertices. And we also have a point on the hyperbola of 5, 4. So that's 3, 4, 5, 2, 3, 4. We can see that it must be going like this. So that tells us that it's opening horizontally, and we'll have x first. With a center at 0, 1, 0, 1, and the horizontal distance is 2, and the vertical distance is unknown. But now we use the x and the y. We're going to place the x with a 5 and the y with a 4. Let's rewrite this. So now that'll be a 5 squared and a 4 minus 1 squared. This will be 3 squared. And why don't we write this as 4 over 4, so that when we subtract that, we'll get negative 21 over 4. And let's multiply by b squared and by the reciprocal of that. So we have negative 9 and then negative 4 over 21. So we get 36 over 21 is b squared. And that's all we need is b squared. We can write the equation as x squared over 4, and that reduces to 12 over 7. So b squared is 12 over 7, and we just write that as the denominator. Alright, pause the video and try that one. Over 1 up 2, over 1 down 2, with a point at 0, 0, radical 5. So this is between 2 and 3. It's opening vertically, so we need to have y first. And the center is 1, 0, 1, 0. The vertical distance is 2, that's under the y, and we'll solve for b. We know the the y value is radical 5. The x value is 0. So that'll be 5 over 4 minus 1 over b squared. And why don't we write this as 4 over 4. And we're going to subtract 5 over 4. So multiply both sides by 4, negative 4, we'll get 4 up here, and multiply by b squared. So b squared equals 4, b equals 2, and we're going to write the equation. Y squared over 4 And x minus 1 squared over 4 equals 1. And that's the end of this lesson.